Good morning.
Morning.
Oh no. The cats are trying to get into my office. Oh, that was quick. We already have 12 half class in. Hey, welcome y'all. I'm gonna just mute everybody's microphones real quick. Let's see.
Test.
Hey. Huh. All right, everybody, welcome to Zoom. I guess we'll just go ahead and try and get started now. So in terms of content, I have today pretty light. We'll get back to like lecturing and stuff tomorrow, but since the school closed, I didn't get a chance to do workshop time for section 8.2. So 8.2 will actually be the first homework assignment of this quarter. I think I changed the due date on Google Classroom. Let me make sure. And as let me just have everybody real quick just mute themselves, figure out how that stuff works, and just make sure you're muted so that, your like random background mic noise doesn't carry through. Though if you have a question, please do like unmute yourself and just ask. Like I think since y'all are the honors group, you should be able to manage that just fine. I was looking at some different app options for Zoom, and I might grab some of the classroom ones, like the one where you can click to raise your hand, but we'll just get on without it for right now. I think what y'all should be seeing is a feed of me, like my webcam, right? You can see my face at home, which is weird. And then you should also be able to see my document cam that I set up. Can y'all see the document cam?
Yeah.
Yes.
All right, cool. So that's how we'll be doing most of our notes. And like, just so y'all know, it's like really ghetto, but it works. It's the way that I used to do notes before I had a smart board. Like literally all that the document cam is it's a downwards facing webcam that I attach to like my lamp. So this is my, camera with the front facing screen on. And then that goes out to a piece of software called YawCam, which lets me do the settings on it. So we'll just be doing notes here as if, stuff was regular. So for today's warm-up, and y'all will be doing the warm-ups like normal, put them all on a sheet of paper, and then at the end of the week on Thursday, you'll be like uploading them, and I'll be reading them there, grading them there, and then moving them to Teacheries. Item number 1, hey, how's it going? It's been a long weekend of people like being weird. So just how are you doing? Like write that out for me and then upload it at the end of the week. And just know that like in these weird times, if you need help or support on anything, either just like extra help with your work, if you want to schedule one-on-one time to chat and do problems, or if you need some sort of material support that I can provide, please reach out sooner rather than later. And then item B, a regular law of cosines question just to get us warmed up for what we're doing for the rest of today. I have some kind of triangle which has side lengths of 5, 9, and 7.5. And kind of just to like kick it off, we should start off by acknowledging that this is not a right triangle. As you can see here, 5 squared plus 7.5 squared gives us 81.25. 9 squared, however, gives us precisely 81. So do the law of cosines, try and solve for the missing angles, but just know that this is not a right triangle question. Since this is slightly off from matching, that tells us that this angle is just slightly off from 90, which is a good way of checking. And just to make sure that we'll all be working on this in the same format, I'll call this A and B and C. The other little announcement that I'll be making to all of my classes today, though, of course, there's no like school-wide Spartan time. So if you have friends who play video games, let them know. I'm going to go ahead and reactivate 8-Bit Club since we're all stuck at home and we'll all be playing video games anyway. We might as well just have a place where we can organize that. So if you would like to rejoin 8-Bit Club for like a Friday afternoon game session, which I'll also be reactivating the Twitch account if you just want to like have it in a second screen while you play your own games or whatever it is, The Google Classroom code for 8-Bit Club is 3QPTDNV. I'll post this like text in Google Classroom as well for anybody who wants to join. And like I said, tell your homies who aren't in any of my classes so that they know too. Are there any questions so far? Is this okay? Oh, cool. I see thumbs up in the chat. Tight. Other thing is I'm going to try to, or I mean, I should say, I will be posting all of these lectures to YouTube, which is awkward, but I think it'll be good simply because, if you miss a class, there's really no other way to make it up. And I don't know, I think it's just like generally useful. I found it useful when I was at UCLA for the professors who podcast their lectures that if I had to go back and review something before a test, it was nice to have that available. So I'll post the link in Classroom. I believe that should work. Try the link that I posted to Classroom, make sure that works. And yeah, all the videos should be going up there, as well as backups of the streams if we end up doing any games that get streamed out for 8-Bit Club. But yeah, take a few minutes on the warm-up question. We'll go over it, and then for the rest of the regular class time that we have, I'll just take questions on the homework. It's due tonight, so do try and wrap it up. And if you have any questions about what's going on, just hop in the chat. Oh, and also, real talk, on that YouTube channel, please do hit subscribe and like or whatever. If YouTube makes the mistake of giving me any monetization money, any money that's made from your clicks or whatever will go towards a class party at the end of the year. Oh, also, if you see me looking off to the left, I have 2 other monitors here that I have my references on. So if I look away, that's why. Okay. Y'all ready to go over this warm-up question here, warm-up question B? And then I can take questions from the homework for the rest of the time. Cool, yeah, I see mostly thumbs ups. Alrighty. So let's go ahead and start off by solving for, I don't know, angle C, just because we know that this is the one that is, we expect it to be about 90 degrees, maybe just a little bit off. And so, like always, I'm going to start off with the law of cosines, and I'm going to start by manipulating for angle C completely in symbols. So this is to say that C squared is going to be equal to A squared plus B squared. Oh, by the way, how's the audio? Before I move along? Yeah, okay. Minus 2 AB cosine C. Just a quick reminder when it comes to using the law of cosines that the easiest way to memorize it is that it's actually just the Pythagorean theorem. So it's A squared plus B squared is equal to C squared. And then there's this little bit of a modifier at the end that has a pattern. It's minus 2 times these letters, A and B, then multiplied by cosine of the angle of the side that's on the other side of the equation. So these 2 letters always match these 2 letters. This angle always matches this side. So what do we do in order to solve for C? What do we have to do first?
Isolate for C, for cosine C, right?
Yeah. So we need to isolate cosine C to get C alone. But to do that, we're going to have to move some algebraic pieces over. What pieces do we move first?
A squared and B squared.
Yeah, we got to get rid of A squared and B squared. So we'll subtract those to the other side. So it'll be C squared minus the quantity of A squared plus B squared. This is going to be equal to negative 2AB cosine of C. And then I'm going to divide both sides by negative 2AB, simply because these are multiplied with the cosine. So to get rid of them, we have to divide. Divide both sides by negative 2AB. Divide both sides by negative 2AB. This and this cancel. On the left-hand side, there might be fancy manipulations we could do if we separated this into multiple fractions. But honestly, leaving the object as it is probably the easiest way to go. And then the last thing we have to do is hit this with arc cosine. And so we can say that arc cosine of c squared minus the quantity of a squared plus b squared divided by negative 2ab. This will give us angle C. Are there any questions up through this step before we plug anything in? No? Okay. So then this is to say that this is the same as inverse cosine of, and when it comes to the sides, it's always matched opposite, matched opposite, matched opposite. This is side C, side B, side A. And so this is going to be equal to 9 squared minus the quantity of 7.5 squared plus 5 squared, then divided by negative 2 multiplied by A and B, which is going to be 7.5 and 5. Yeah, and feeding this to our calculator should give us back angle C. And so we can go ahead and do that. So that's going to be inverse cosine. Oh, and before we do any of this, let's go ahead and make sure that our calculator is in the correct mode. It is to say mode, radians, probably want to do this in degrees since it's trig. Go back to the top menu. So it's going to be inverse cosine of 9 squared minus the quantity of 7.5 squared plus 5 squared. Oh man, this is really weird. I can't read the calculator at all from this angle, right? Because like my hand's here, my hand's here. So I'm looking at it on my own computer screen and there's a weird delay between when I press the button and when it shows up in the feed, and it hurts my brain, but I'll get used to it, I'll live. Anyway, so I'll actually need to separate out the numerator of this, and if you didn't know, you could insert characters in your calculator by hitting second insert, which is right above the delete key. So I'm just adding in one extra set of parentheses so that everything here is contained within its own set of parentheses just to represent the numerator. Now I can divide by the terms in the denominator, which is going to be negative 2 times 5 times 7.5. Close the bottom parenthesis, and then I'm going to use another parenthesis to close the entire cosine term. And now I'll hit enter. And like we expected, because this triangle is close to 90 degrees, I'm sorry, because the sides are very close to fulfilling the Pythagorean theorem, this angle is very close to 90 degrees, but not spot on. And like normal, like in our conventions in here for rounding to a decimal, just hold 2 decimal places unless you're given other instructions. So this is to say that angle C is 89.81 degrees. And that's the first little bit here. Are there any questions on solving for angle C?
Mr. Robinson, quick question. When you without inverse cosine, just what's in the parentheses, what does that equal to? Because I got 12.96, and it's showing me a domain error.
Yeah, so you can't take inverse sine or inverse cosine of anything outside of 1. Keep in mind that sine and cosine oscillate between 1 only, so you can't get values outside of that. Really easy to check. So what I just did was I hit second enter, which is entry. It just copy pastes the last thing that I put in. Now I'm going to hit delete to delete the inverse cosine part and hit enter again. Oh, heck.
Yes, yeah.
Parenthesis error. So it's parentheses, parentheses, oh, one extra parenthesis. So the thing that you get on the inside of your fraction should be 0.003, or if you turn that into an exact fraction, it should be 1 in 300. Double check your parentheses. You're probably missing a set of parentheses in the numerator.
Okay, thank you.
Good. Okay, so now let's go ahead and get to solving for one of the other angles. And could I have, oh, Sean, you raised your hand. Wait, how did you do that?
It's in the more area.
Amazing. Okay, so what was your question?
It was, so this is for any triangle. After we do one set of law of cosine, everything else we could solve in law of sine, right?
You answered my next question literally seconds before I asked it. But yeah, that's spot on. So
Okay.
once you have one of the angles by the law of cosines, you could use the law of cosines again, and that would give you a correct answer, but you're doing way too much work at that point. So yeah, from here forward, we should use the law of sines, and even then, we only actually have to use the law of sines once, because using it twice, again, would give us a correct answer, but if you use the law of sines twice, again, you're doing too much work. So let's go ahead and get one of the other sides by using the law of sines, and let's just get angle B, no particular reason. So once we have this first part, right, it's going to be sine of B over B is equal to sine of C over C. Even though the law of sines has 3 parts, we only ever use 2 of them at a time. And so we're solving for angle B, and just like here, how we should always do it purely in variables first, and then only plug in values on the last step. So I'm going to do the same thing here. Multiply both sides by sine B. That tells us that sine of angle B is going to be equal to B sine C over C. And now I'm going to hit both sides with inverse sine. Angle B must be equal to inverse sine of B sine C over C. And now all we have to do is plug in these values. So B must be equal to inverse sine of 5 sine quantity 89.81, then divided by 9. And again, since we're on document cam, it's really easy for me to show y'all like how you want to enter this. So it's going to be inverse sine of 5 sine 89.81, then divided by 9, all on the inside of the first inverse sine. We hit enter, and that gives us back 33.75 degrees, because like I said, since we're being heathens and we're, getting decimals, we'll round and we'll just hold 2 decimals as a standard for whenever we round stuff. So this is going to give us back 33.75. And now could I have somebody else raise their hand and tell me what is the easiest way to get the final angle? Heiko?
Third angle theorem.
Yeah, third angle theorem. So that is to say that so long as I have 2 angles of a triangle, I always have the third. Their sum is 180, right? So that is to say that angle A plus angle B plus angle C is equal to 180 degrees. So all we have to do is add up these 2 guys and subtract them from 180. So that's going to be equal to 180 minus the sum of 89.81 plus 33.75. And that gives us 56.44. So this is to say that angle A is equal to 56.44 degrees. And that gives us all 3 angles of an not obtuse, but what's the word for not right? Having a brain fart. We've had too many days off.
Obsolete.
Oblique.
Oblique, that's the one, thank you. And that's how we solve for the angles of an oblique triangle. First step, use the law of cosines to get the first angle. Then after you have that, use the law of sines to get the second angle. And after you have 2 of them, you use the third angle theorem to get the third angle. Hey, though don't get me wrong, if you really, really like the law of cosines, if you like doing this, you could do this 3 times in a row, and that would also give you the exact same set of answers. This time is yours to work, and like I said, we're going to try and maintain some semblance of normalcy in these trying times. So we're just going to work through till the end of the normal class period at 9:10, and then I'll end the stream, I'll download it, and then once it's downloaded and encoded, I'll upload it to YouTube. So if you want to see this problem again, you could look over it. This time is yours, and if you have a question on the current homework assignment that's due tonight, just hit raise a hand. I'll take your question, and I'm just hanging out all day at my house with the cats and this document cam and a pad of paper. So if y'all have any questions on the homework, I'll work them out here or at least give you guidance on how to do them. Hmm. Natalie, did you have a question?
Yeah, for the law of cosines, can you only use it if you're given all all the sides, or like the two sides and then the angle of like the side that's not given?
Yeah, so there are two cases where you want to start off with the law of cosines, either all three sides or specifically SAS. And whenever we use that triangle language, the order matters. So it is to say I have two, I guess this window is bigger for y'all, right, than my face is. So
Yeah.
if I have two sides, this length and specifically the angle in between them, yeah, that is the other case in which you would want to use law of cosines, because what the law of cosines recipe will give you is it'll immediately give you the opposite side of that triangle.
Oh, okay.
Sean?
If we finish the homework, is there anything else we could work on, or no?
No, not right now. And that's a good question. Let me talk a little bit about like where we're headed in the coming weeks. The OWS is filled out basically up until spring break, just so that y'all know what we're doing. And today is the last day that we'll be discussing trig openly like this. After today, tomorrow, we're going to switch to lecture on something new, and it's something that you're really good at. It's something that y'all have been doing since middle school. We'll be solving systems of linear equations for their solutions, but not, just because it's fun and easy. It's going to build up to some new skills. We're going to talk about solving linear equations of two variables, x and y. Then we're going to talk about solving linear equations of three variables, x, y, and z. Then we're going to talk about solving nonlinear systems. So if I have a parabola and a line, they cross in two places. How do we figure out those two places? That's a skill that you end up using a lot in calculus. And then in section 9.4, which is the last section that we'll do before break, in 9.4, we'll talk about systems of inequalities. It's the same as graphing. The only difference is when you have an inequality, you either shade up or shade down. We'll talk about all that stuff. And then on the last day of class, before we go off to spring break, we'll have a mid-chapter quiz, and it'll be take-home of a college style. Basically, I'll upload the quiz in two parts. The first half will be multiple choice with randomized choices. The second half will be free response, and we'll all take it at a set time, and you'll all have a limited amount of time to take the test and then upload your work to Google Classroom. So all we have in the next 2 weeks are 4 sections of homework that we'll do like this, conducted like normal class, and then at the end we'll have a take-home quiz. Is that okay?
Yep.
Cool. And also, let me show y'all a little bit of like science, I guess, while y'all continue working on your triangles. So if you have any questions, just holler. If you're watching my feed, I would recommend you don't stare at it for a second because you're about to get disoriented. I'm going to move the camera, which might cause some motion sickness. Oh, my binder clip. Oh my God. Okay, it's fine. Just hold on. So here's this meta. It's my laptop. Here's my desktop computer, which has like my Cuphead stickers, and I don't know, this weird thing from Mexico. But in there, I got like a beefy video card running. I posted about it on Classroom, so I don't know if y'all can see it. That thing right there is a protein, and my computer, since I'm not using it right now, my video card is running mathematical simulations on that protein to see how it folds. And over here, it has the breakdown of like exactly how much math I'm doing. Oh, hey, we got to run it on full settings, full power, right? It doesn't use that much internet. It mostly just uses a bunch of electricity to do this math. But folding at home is really cool. It basically decentralizes biological research. So all of the computers in the world who are doing this, a few million of them working together, has basically the same power as a supercomputer, which sounds like it doesn't help, but if we have access to one supercomputer to do research for our project, and you have access to folding at home, right? It's going to double the amount of processing power that you have. Right now, people are using folding at home to help with the COVID-19 research. So if you have a desktop computer that you know, is mildly powerful. Folding at home, the links are in Google Classroom, like I said, is a way that you can actually help the research towards finding treatments, or preferably a vaccine to the virus that's going around. It's a really good piece of software. It's really exciting. And now let me put the thing back. Oh, one other thing as we switch to online learning. Y'all can see right here that I'm like keeping a paper copy of the notes. I'm going to be filing these for the whole time that we're doing remote learning like this. So if you ever are missing a note, or if you're ever absent or whatever, just shoot me an email and I'll scan and upload it. I'll be keeping all the notes up until my cats locate and destroy them. Any questions from the homework out there? Just so y'all know, I can't see all of your like tiles at once. They get separated into 3 windows because of how big this group is. So if I'm ever slow to responding to a question or whatever, that might be why.
Mr.
Yeah, Chris?
Oh, one sec. Yeah, wasn't the homework due like a few days ago?
Oh yeah, of course, but you know, everything got messed up with I don't know, the virus, the world reacting to that. So let me go ahead and just fix that.
Okay.
Classroom, classwork, edit. Man, I need a 4th monitor. Oh, no, it says, yeah, it says it's due tonight. I changed that when I updated. Today is the 17th, yeah?
Yeah.
Yeah, it's updated on Classroom. So y'all have until 10 p.m. tonight. Though I believe I already got a lot of them in just from people who had already done it. Oh, Oogie?
Yeah.
Oh, my cat's screaming outside. I'm gonna let him in. He does not like being locked out of this room. Oogie, come here. You want to say hi to my pre-cal class? Come here, boy. Come here. Yeah. Oh, look at this guy. Look at that guy. I don't know if you can hear him purring. He has no idea what's happening. He just knows that he normally sleeps in this office at this time and he doesn't know why the door is closed. There you go, buddy. Oh, I see why I'm not getting that many questions. I already have 18 turned in of the 5. I'm sorry, 18 turned in of the 23, which means only 5 of y'all are still working on it. Hey, I mean, I'm sure you're already like doing something else if you're not paying attention to this feed, which is fine, you know. We're all learning from home. So if you have other stuff to work on, if you are one of the 18 people who have it turned in, great. Tomorrow we'll have a full-blown lecture on the document cam. But if you're one of the 5 still working on it, if y'all have any questions, if you want to see me do a homework question, just, you know, holler. We have about 25 minutes left of regular class time.
Mr. Robinson, are we allowed to log off, or should we just stay on?
Oh yeah, that's a good question. If you have already turned in the current assignment, feel free to log off and do whatever as you wait for your 2nd period class to start.
All right. Yeah, I guess I'll do that because I finished.
Yeah, for sure. Yeah, take it easy.
All right. All right, see you.
Bye. Sean, did you have a question?
Yeah, was this the chapter that wasn't going to be on the quiz, or was that the previous lesson?
So both 8.1 and 8.2, neither of them are going to be things that I quiz y'all on because they're review sections from geometry. I just want to make sure that we talk about them this year, because next year when y'all take physics, you'll have to do math with vectors. And this is a necessary skill to be okay with that. But this section, 8.1, Law of Sines, 8.2, Law of Cosines, this trig won't appear on the final.
Okay, thank you.
Yeah. Oh, I got 2 raised hands. Stupid thing. How do who raised? Wait, it said 2 raised hands more. Oh, Harag, what's up? No?
Me?
Yeah, it says you have a raised hand.
Oh, really?
Yeah.
Oh, I didn't raise my hand.
Oh, okay.
Okay. Sorry.
No, that's cool. Okay.
Yeah, Mr. Robinson, I already finished the homework, so I guess I'll log off too.
Yeah, that's fine. Yep.
Sweet. All right. See you.
Peace. Yeah. If y'all turn it in the same way how like we're in class, if you upload your work and it's good to go or whatever, and you have another thing to do, feel free to hop off, go do your reading.
Mr. Robinson?
Yeah.
I was gonna ask, do we have to turn in the do nows by the end of the week?
Yeah. So normally I just take the do nows in person, but since we're all at home, at the end of the week, I'll make a assignment in Google Classroom, like right at the top of the period that just says classwork week 1. And yeah, you'll just take a picture of it and then upload it there.
All right, sick.
Yep. Oh yeah, and I have another thingy to plug, I guess, for everybody stuck at home. I don't know if you know, or I've talked about this before, but there's an app that you can get on your phone called Office. Whoa, that's real potato-y. Is any of this readable? It just looks like blocks, right?
Yeah.
Anyway, there's an app you can get called Office Lens, and here's what makes it cool. It's a Microsoft product, and the reason why it's exciting is that if you use it to take a picture of a document, so let's say I use it to take a picture of the notes that I did today, it automatically takes it and it basically photoshops it to look nice. It makes the white background white, it makes the black text like very black, and it'll even let you export as PDF. If you want to make sure that the stuff that you were scanning and uploading with your phone looks crisp and clear, I would recommend using this to take pictures of it instead of just taking regular photos. Like as long as it's readable, it's fine. But this is also useful in college if like you need to take a picture of a blackboard before somebody erases it. Does the same thing, makes it nice and crisp and easy to read.
Hey, Mr. Robinson, what was the name of the app?
Office Lens from Microsoft.
And also one more thing, do we have a chat this Friday, like a Zoom meeting?
No, Friday is a pupil free day, and again, we're trying to maintain like the same schedule we had planned out in advance. So y'all will have the day off on Friday. It'll just be me and the other teachers having a Zoom meeting just to see how everybody's doing.
All right.
Yeah, and I might try and, I don't know if, like, because today you're going to see a lot of people trying a lot of different stuff. I really like this document cam setup because it lets me conduct the class basically the same as normal. I might help some other teachers set this up if they're interested.
Hey, Mr. Robinson,
Hey.
do you honestly think by the end of like the month they're gonna let us come back to school, like with the condition it's in right now?
I don't have the technical expertise to make that call, but y'all saw a while ago in the I posted that like 3-part update to Google Classroom, where I mentioned those products that were free, but at the last thing on there was that YouTube video, that 3 brown 1 blue video, that describes the mathematics of this particular viral infection and what to expect. The scary thing about exponentials is the fact that they can take several different trajectories based on the initial values plugged in. Like the difference between an infection expanding and an infection dying out is whether or not its multiplier is 1.1. If it's 1.1, it'll keep growing. but if it's 0.9, it'll, you know, shrink back down to 0. There's not enough information yet to make that decision, but so long as everybody maintains, you know, the active social distancing combined with excellent hygiene and quarantining of those who are definitely sick, the goal is to get that multiplier down below 1 so that the infection will shrink instead of grow. It's a question of how many people out there are currently infected and what do people do in response to that moving forward in the coming days. The tail end of it, yeah, I couldn't give you a number responsibly. I'd have to do some math.
All right. Thank you.
Yeah, it's a good question. But like I said, in these times, if any of y'all run into unique circumstances or need any type of support that I can provide, you know, let me know. Just shoot me an email or message me through Google Classroom. Checking on my protein folding over here. Also, instead of running the heater, for folding proteins at home makes my computer very warm. It's basically just blowing hot air in my face. It's great. We have about 10 minutes left of regular class time. Do any of y'all want me to work a homework question? Oh, hey, I got subscriptions. I'm famous. Be sure to mash like and subscribe, y'all.
All right, Mr. Robinson, thank you.
Mm-hmm.
See you.
No math questions out there? Just crunching away at the homework? Oh, yeah, you are. Yeah, okay, I got 19 turned in. I got 20 turned in. Oh yeah, and then in tomorrow's warm-up, I'm gonna remember to ask y'all what the other teachers are doing, just because I'm not tuned into their channels. If somebody's doing something better than I am, you know, let me know. I got that healthy competitiveness in my brain. I want to make sure that if we're doing this, we're all like doing it the best that we can.
Wait, I have a question. Does anyone know if Daldurian is doing this, like the online thing? Because I didn't get an email from him.
No, Armenian teachers are doing it, Armin.
Okay.
Oh.
So we just have free time after?
I mean, I don't know. Laura's making us write an essay every week, but
No, Daldurian hasn't said anything.
yeah, I don't know.
And Markaran hasn't sent a thing, an email with the code, or is it on Classroom?
I don't think so. I think she's gonna send it like when it's our class time.
Okay.
Meeting.
Mr. Robinson?
Yep.
Did you post the link to your YouTube channel on Google Classroom?
Yeah.
All right.
Yep. Yeah. And like I said, every day, as long as like I think I know how this works. I have Zoom set up so it records locally to my laptop. And then after it downloads and encodes the video, I should just be able to upload it right to YouTube. And I'll be doing that for all of the like normal lectures that we hold. So if you want to do a review of it, you can. This one's kind of contentless, but I think it'll be mostly useful on the days that I do lectures.
Hey, Mr. Robinson, instead of getting like a fourth monitor, like you were saying, you should probably get an ultra wide. Like I honestly like highly suggest it, like for multitasking.
I've always had, even if I had an ultra wide, I would still have one small one on the side.
Oh yeah, definitely. Yeah.
Mostly because I like having one 4x3 monitor, because most of the games I play are old, and it's cooler to have an actual 4x3 in my opinion than it is to have like a 16:9 with black bars on the sides. An ultra wide would be nice for my main screen, but no matter what, I'll always have a 4x3 for emulator stuff.
Yeah, I kind of recently took out all three of my monitors and replaced them. I have a 34-inch ultra wide as my main, and then like a 24-inch ultra wide, 25-inch ultra wide. Like it's like vertical, so it's running 4:3, but vertical.
Mm-hmm.
And I like keep Spotify on the right and like Discord and stuff like that, and then the rest of it is on the 34-inch, and I have like plenty of real estate.
Yeah. My my wide monitor, it's not ultra wide, but my normal 16:10 monitor is also on a 90-degree bracket. Because when I am reading, I probably won't turn it all the way. This monitor is on a 90-degree bracket. Rotates. Yeah. Watch me just like throw it on the ground. Yeah, it rotates this way. It's nice to set it to 90 degrees so that you can like set a PDF lengthwise and read it if I'm reading textbooks. But in terms of my like little battle station to get through this, yeah, I just have like the textbooks over here on this screen. It's like fine.
Yeah.
Finally putting all this like expensive technology to use, I guess. Like this is why I hoarded all this stuff. Anyway, there's just a few of y'all left in the chat. Like I said, once you're done, feel free to hop off, or if you have any questions, I'm like more than glad to work them out. Start to finish for you, because boy, I'm bored. Oh, bye everybody. Bye. Did you have any questions, Lucine? Okay, if there's no questions, I'm going to hit stop share just so that I have time for the video to encode and download before my next class. Y'all have a nice day, and I'll see you tomorrow morning, same time.